Good evening, good afternoon. This is Bill, Computer Science 221. We're going to learn some new stuff and review some old stuff. This is right out of Chapter 2, so you should be reading it. And I basically want to talk about bits and bytes and signed numbers and unsigned numbers. So again, why don't we begin with unsigned numbers? Unsigned integers. And remember, for this all to make sense, we have to talk about the size of the thing. So basically what I really want to talk about here for the moment, I want to talk about 8-bit unsigned integers. Now you can look in your book and there are all sorts of fancy algorithms in there. I tend to think about these things in a much simpler way. If we're talking about 8 bits, remember we said you're going to have 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. And again, if you come here and you figure these numbers out, that's a 1, that's a 2, 4, 8, 16, 32, 64, 128. So if I come along here, and I have an 8-bit number, and let's make sure we have 8 squares for it. And suppose the number is something like this. Okay. What we do here is we just go, well, there's a 1 there. Okay, from that. Over here, I see that there's a 2. There's no 4s, there's no 8s, there's no 16, there is a 32. There's no 64, there is a 128. So that's 8, 9, 10, 11, 12, 13, 3, carry the 1, that's 4, 5, 6, that's 163. So in other words, 1, 0, 1, 0, 0, 0, 1, 1 in base 2 is equal to 163. In base 10. And I think that that's pretty simple. I think that you folks can figure out other things like that. Now if I want to go the other way, so that's going from binary to decimal. If I want to go the other way, how do I write, say, let's make up another number here, 175 as an unsigned 8-bit integer? Well, actually this table that I've drawn up here can help me do that. I've got 175, and I can see that 175 is going to contain 128 in it. So I come over here and I go 175, and I know that there's going to be 128 in it. So I'm going to put a 1 here, and I'm going to go ahead and subtract. Now when I subtract, I get 15 minus 8 is 7, and let's see, that 7 becomes a 6, 5, 4. So there's a 47 in there. Well, there's no 64 in a 47. So that's a 0. There is a 32 in there. So if I go 47, I know there's going to be a 32. And I subtract. And I'm left with a 15. So that was a 32. There is no 16 in a 15. So I'm going to put a 0 there. Okay, there is an 8. So I'll put a 1 here for an 8, and I'll subtract 8. and that leaves me with 7. And there is a 4 and a 7, so I'll put a 1 there, and I'll subtract 4 from 7, leaves me with 3. There is a 2 and a 3, so I'll do that. That leaves me with a 1, and there is a 1 and a 1. So notice over here I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 bits, and that in base 2 is equal to 175 base 10. Okay, so now what we want to do is I want to consider signed 8-bit integers. And remember, we do this for signed numbers, we do this weird thing. We use something called 2's complement notation. And remember, what that does is if we want to convert a positive to a negative integer, or actually if we want to go the other way around, if we want to convert a negative to a positive, it's a 2-step process. So there are 2 steps. So the first step is complement, which is another fancy way of just saying invert the bits. And then number 2 is you add 1 to result from 1. Okay, so let's consider an example here. How do I write minus 7 as an 8-bit signed int? Well, the first thing I need to do is I need to figure out how do I write plus 7. And plus 7 would be, 1 plus 2 plus 4 is 7. And what I have to do is I have to make this into 8 bits. So that's 4 bits. 5, 6, 7, 8. So this base 2 is equal to 7 in base 10. So now what I can do is I can take this number right here and I'm going to apply these 2 steps to it. So step 1 is I invert. And when I invert, that's going to give me 1, 2, 3, 4, 5 ones. 1, 2, 3, 4, 5 ones. And then it's going to give me 3 zeros. Okay, and then I do step 2. To this, I'm going to add 1. And I come over here, and that gives me 1, 2, 3, 4, 5, 6, 7, 8. And this number right over here in base 2 is equal to minus 7 in base 10. There are a couple of things to note here that will help you out. When you're looking at signed integers, the leading bit does indicate to you what the sign of the number will be. If I see a 0, it's going to be a positive number. If I see a 1 over here, that indicates that it's going to be a negative number. Okay, let's take that a step further. Suppose I were to ask the following. What decimal number is represented by 11010011, assuming this is an 8-bit signed int. And I look at that, and I don't know any quick way to figure out what number this is, but I do know the following. I see that the leading bit is a 1, and that immediately tells me that that is a negative number. So what I'm going to do with this negative number is I'm going to find the 2's complement of this. That'll give me a positive number. I can figure out what number or what integer that is, and then I'll just stick a negative sign in front of it. So the first thing I'm going to do is I'm going to look at 11010011, and I'm going to invert all of the bits, and that gives me 0, 0, 1, 0, 1, 1, 0, 0. And then what I'm going to do is I'm going to add a 1 to it. And that gives me a 1, 0, 1, 1. We have some road noise outside. 0, 1, 0, 0. And I take a look at this and I go, okay, what number is this? Well, that's a 1, that's a 2, that's a 4, that's an 8, that's a 16, that's a 32. So it's going to be a 32 plus an 8 plus a 4 plus a 1. So that's 8, 9, 10, that's 15, carry the 1, so that is 45. So that says to me that this number right over here, that's minus 45, base 10. Okay? You should practice a few of these. You should be able to go from 8-bit signed integers to decimal, and from decimal to 8-bit signed integer. All right, I have a couple of theoretical questions, something to just sort of ponder here. I want to talk about 8-bit unsigned for a moment. And I'm going to go, what is the range? Okay, and when I say what is the range, I mean what is the smallest and biggest 8-bit unsigned int I can have? Well, I think you can see that the smallest 8-bit unsigned would just be 8 zeros. And of course that's just equal to 0 base 10. And again, the largest, so this would be the smallest, the largest would be all of those right there. So what number is that? That's 8 ones. Well, that's a 1. That's 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And I will leave it as an exercise for you to verify that that is the number 255, base 10. That's the largest. Okay? What happens if I want to talk about 8-bit signed? And I go, what is the range? Well, here I've got to do a little bit more thinking, okay? So if I've got 8 bits to me, remember, if I want to look at the positive numbers, what's the biggest number I can have? Remember, the leading bit has to be a 0. Remember, if that's a 1, it's a negative number. So if you think about it, okay, that's 8 bits. And you should recognize that that's got to be the largest integer that I can represent there. Okay? And the reason for that is remember, if this over here were a 1, it would be a negative number. So the question is what is this number? Well, it's all of these except the 128. So it's going to be 255 minus 128. That's 127. So this is equal to 127 base 10. Okay, and here's something that's a little bit weird. What would be the smallest? Well, let's calculate the 2's complement of this thing right over here. If I calculate the 2's complement of that thing, first I'm going to flip all the bits. And then I'm going to add 1 to it. Huh. Well, it turns out that's equal to minus 127. Okay, so this would be the largest here. And this would be the smallest here. Now you might be wondering, what number is this? Okay, well I look at that number and I see that it's got the leading bit is a 1, so I know it's a negative number, and I go, okay, what I need to do is I need to calculate the 2's complement of this thing and see what the inverse of it is. So if I calculate the 2's complement of it, I get 0, 2, 3, 4, 1, 2, 3, 4, and I go ahead and I add a 1 to it, and look at what happens. This becomes a 0, carry the 1, and this becomes a 0, carry the 1, 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 and it's that. And I go, huh, that's kind of strange. The 2's complement of that is just itself. Well, if you think about it, that means that this thing over here is just another way of saying 0. It's 0 base 10. Turns out there are 2 ways, if you're going to consider 8-bit signed ints, there are 2 ways to say 0. This is one way to say 0. This is the other way to say 0. And if you take this and calculate the 2's complement of it, you're going to get the same thing right back again. So there are 2 ways to say 0 here, and here are the ranges on our 8-bit signed integers. Greetings again. We just review for a second. Addition and subtraction. Suppose, and for the rest of this discussion, I want to suppose we are using eight-bit signed ints. So again, first let's talk about addition. Excuse me. This is pretty simple here. Suppose I wanted to add, I don't know, 17 plus 25. Well, 17, I recognize 17 is equal to 16 plus 1. So that's a 1, 2, 4, 8, 16. Okay, so 16 plus 1 is 17. I've got 5 bits. I just need to add 3 more. Okay, 25 is equal to 16 plus 8 plus 1. So I've got 1, 2, 4, 8, 16, like that. And we've actually reviewed how to do this in class before. Basically, when you have binary and you're adding 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is a 0, and you carry a 1. So what happens over here is as I go, there's a 0, and I carry the 1, there's a 1, that's a 0, 1 plus 0 is a 1, 1 plus 1 is a 0, I carry the 1, there's a 1 here, 0, 0. So let's take a look at what's going on over here. That's a 1, a 2, a 4, an 8, a 16, a 32. So it looks like it's 32 plus 8 plus 2. So that's 8, 9, 10, 11, 12. Carry the 1. That's 42. And sure enough, 17 plus 25 does equal 42. So that seems to work. Okay. Suppose I wanted to add, just for fun, suppose I wanted to add minus 17. Let's do it. Minus 17 plus minus 25. Well, the first thing I need to do, remember this over here is 17. This number over here is 25. I need to calculate the 2's complement of each one of them. So first what I have to do for 17, I'm going to complement all of these bits, and I get 1, 2, 3, 0, 1, 2, 3, 0. So that's complementing the bits, and I'm going to add 1 to it, and I get 1, 1, 2, 3, 0, 1, 2, 3. So that's 1, 2, 3, 4, 5, 6, 7, 8. And remember, this is minus 17 is equal to that. 25, again, I'm going to complement the bits. I get 1, 2, 3, then I get a 0, 0, then I get a 1, 1, 0. Let me count. Make sure 1, 2, 3, 4, 5, 6, 7, 8. I have complemented the bits. I'm going to add 1 to it. So I get 1, 1, 1, 0, 0, 1, 1, 1. Okay, so this is equal to minus 25. And now what I'm going to do is I'm going to add these together. So I'm going to come over here, 1, 1, 1, 0, 0, 1, 1, 1. So 1 plus 1 is a 0, carry the 1. So here I've got 1 plus 1 is 0, plus 1 is a 1, and I'm going to carry the 1. Here's 1 plus 1 plus 1, well that's going to be a 1, carry the 1. 1 plus 1 plus 0 is going to be a 0, carry the 1. So there's a 1. 1 plus 1 is a 0, and I carry the 1, and that's going to be a 1, carry the 1, and that's going to be 1 plus 1 plus 1, that's a 1, and I'm going to carry the 1, but remember, I am only talking about 8 bits. Here are my 8 bits, and what happens to this carry over here? Well, I got no place to put it. Well, you might think that that's worrisome, and there are times when it is worrisome. We'll discuss that in about 5 minutes. But now, we know that minus 17 plus minus 25, this should be equal to minus 42. So I'm hoping that this number over here is minus 42. Well, I see that the leading bit is a 1, so I know it's a negative number, but I don't know what number this is. What I'm going to have to do is I'm going to have to calculate the 2's complement of this. So if I come over here, and I calculate the 2's complement, I'm going to get 0, 0, 1, 0, and then I'm going to get 1, 0, 0, 1. Did I do that correctly? I did. And now I'm going to have to add a 1 to it. And I'm going to get 0, carry the 1, so that is going to be a 1, 0, 1, 0, 1, 0, 0. And what happens is this number right here is exactly the same number that I got right over here. This number right over here we calculated was 42. So this number over here, this is in fact minus 42. So addition is not very difficult. Subtraction isn't either. And I am going to leave that as an exercise, but I'll give you the basic idea. Suppose I wanted to do the following. Suppose I wanted to do something like 46 minus 89. And I go, Well, but remember, that's the same thing as saying 46 plus a negative 89. Okay, so what we need to do here is we need to calculate 46 in binary, and we need to calculate negative 89 in binary. Okay, you got me? I'll do it myself. 46 is equal to 32. There is no 16, there is an 8. Okay, 32 plus 8 is 40, plus 4 plus 2. So 46 is going to be, there is no 1, there is a 2, there is a 4, there is an 8, there is no 16, there is a 32, there is no 64. 1, 2, 3, 4, 5, 6, 7, 8. Right there. So this number right here is 46. Now, I don't know how to calculate minus 89, but what I do know how to do is calculate 89. And 89 is equal to 64. So if I come over here and that's a 64, that's a 5 and a 2. So that is 64 plus 16. That would leave me with a 9. Well, that's plus an 8 and a 1. So I'm going to come over here. So that is going to be a 1, 2, 4, 8, 16, 32, 64, 128. But that's positive 89. I want negative 89. So I'm going to complement the bits. 1, 0, 1, 0, 0, 1, 1, 0. And I'm going to add 1 to it. And that gives me 1, 1, 1, 0, 0, 1, 0, 1. So this is equal to minus 89. And now what I'm going to do is I'm going to just go ahead and add these numbers together. So I've got 1, 0, 1, 0, 0, 1, 1, 1. And we said that 46 is this number right up here. So that is 0, 0, 1, 0, 1, 1, 1, 0. And I'm going to go ahead and add these. And that gives me a 1, and that gives me a 0, carry the 1, and that gives me a 1, carry the 1, and that's a 0, carry the 1. So 1, a 0, carry the 1, 1, 1. So here's my answer. The question is what is that number? And the answer is, I'm not sure. I see that the leading bit is a 0, is a 1. That tells me it's a negative number. What I'm going to do is calculate the 2's complement of that. 0, 0, 1, 0, 1, 0, 1, 0. And I'm going to add a 1 to it. 1, 1, 0, 1, 0, 1, 0, 0. So that is a 1 plus a 2. 1, 2, 4, 8. 16, 32. So that's 43. So that says to me that my answer is minus 43. I don't know. Does that look right? Well, if I go 89 minus 46, that's going to be a 3, and that's going to be a 4, and then I just have to switch the sign. Minus, so this is a positive, but if I go the other way, if I go 46 minus 89, then that should be minus 43. And that's exactly the answer I got. Cool. Everything seems to work. Okay, so that brings us to, whoops, here we go. We need another thing to write on. I want you to consider the following. Remember we said that the range for 8-bit signed was from 127 all the way down to a minus 127. Now remember we said 127 is this number right here. 2, 3, 4, 6, 7, 8. Let's consider the problem. If that's 127, this number over here is 126. Okay, it's just one less than that. And let's consider another number here. Suppose I did this, 2, 3, 4, 5, 6, 0, 0. Now notice that there's no 2 here, so if that's 126, this is 124. Now, what happens if I add 124 and 126? Well, that's a 0, carry the 1, that's a 5, and a 2. That's out of range, okay? Notice I can't, if I'm talking about 8-bit signed integers, I can't add these two things together because it's too big. It doesn't fit in this range. I have what's called an overflow. Well, the question is how would I know that I have an overflow? Well, let's come over here and let's add these two together. And when I add them together, I get a 0. Here I get a 1. Here I get a 0, carry the 1. Here I get a 1, carry the 1. Here I get a 1, carry the 1. Here I get a 1, carry the 1. Okay? Over here, I get a 1, and I carry the 1, and there's a 1 over here. Now, immediately, I should notice that there's a problem, because I've added two positive numbers together, and look what happened here. I got an 8-bit number where the leading one is a 0. I might think that this is a negative number, okay? So there's an overflow condition here, okay? I don't quite know how to determine it yet, but I will show you that in a moment. Likewise, if I came along and what would happen if I did like minus 126 plus minus 124? Okay, now we know that if I'm going to add those two things together, again, that's going to be minus 250. And again, we see that that's outside the range. Well, let's see what these look like. If that's 126, I'm going to calculate the 2's complement, and I'm going to get 1, 0, 0, 0, 0, 0, 0, 1, and then I have to go plus 1, and that's going to equal 1, 0, 3, 4, 5, 6, 7, 8. And if I come over here, minus 124, well, I'm going to flip the bits. I'm using these bits right over here. I'm going to get 0, 2, 3, 4, bump, bump, 0, 1. And I'm going to add a 1 to it. Whoops, I've made a mistake here. Copied the wrong bits. I want to flip the bits here. So I'm going to get 1, 2, 3, 4, 5, 6, 1, 1, and I'm going to add a 1 to it, so that's going to give me a 0, carry the 1, and that's going to give me a 0, carry the 1, so I've got that over there, and then everything else is zeros up to the leading 1. And I'm going to go ahead and I'm going to add these numbers up. Notice these are both negative numbers. I have a leading 1 here, but when I add them up, and what happens over here, I go 1 plus 1 is a 0, and I carry the 1 over here. Okay, but notice I've already got my 8 bits in there. I can't do anything with this one. But here you see the same sort of problem as before. I am adding two negative numbers, and I'm apparently getting a positive number. It's just the opposite problem of over here. Well, what's the problem? How can I, so some people refer to this as an overflow and they call this an underflow. I tend to call them both overflows. In other words, what's going on is in both of these situations, there is a problem, okay? We're not getting an accurate answer. We're trying to calculate a quantity that is too big to stick in the range of the given variable type that we're talking about. How do you recognize it? Well, the answer is, I don't know if we have that example available to us from a previous one or not. We have to look at these carry bits. And basically what's going on is the following. We've got an 8-bit number over here. And we've got another 8-bit number over here. And we're trying to add them. And basically, I want to talk about two things here. We have to talk about, remember, there's always the possibility that you can add up a column here and you may be carrying a bit over to the left. Okay? So what I want to do is I want to number these bits. And I'm going to call this bit 0, and I'm going to call this bit 1, and it comes all the way over here to bit 7. There's bit 6, there's bit 5, bit 4, bit 3, bit 2. And what I am curious about are two things. I am curious if there is a carry into bit 7, or I'm concerned about whether there is a carry into the 7th column, and then I'm also worried about whether there is a carry out from the 7th column. Now remember, I'm saying 7, we're starting at 0. It's actually the 8th bit. Now the thing that I want you to notice in both of these over here, in this example here, there was a carry out. A carry out from bit 7. Okay? And over here, I want you to notice that there was a carry in. There was a carry in from bit 7. Okay? And the criteria for overflow, let me move this over, and I think this is all going to fit on your screen. Let me get another one here. So I think you can see this spot. So overflow. Okay, so I'm going to call it carry in on bit 7 is equal to 1, and carry out on bit 7 is equal to 0, or carry in on bit 7 is equal to a 0, and carry out on bit 7 is equal to a 1. This is when you get an overflow. In other words, if the carry in is 1 and the carry out is 0, that corresponds to this example over here, and that's an overflow. If the carry in is a 0 and the carry out is a 1, that's an underflow. And in either case, your answer is in error. Okay? So, but here's the other thing now that you need to remember. I'm going to move this over a little more. If the carry in on 7 is equal to 0, and the carry out on 7 is equal to a 0, or the carry in on 7 is equal to a 1, and the carry out on 7 is equal to a 1, I'm going to say everything is okay. And we actually had examples of this in a little bit earlier in this video. If you take a look at it, you'll find it. So this is the criteria for it. So another way to do this, I'll leave this as something for you to think about. I could say carry in on 7, and I'm going to say exclusive OR. This is the condition for checking for overflow.